Okay, in this video we're going to continue with part 3 where we left off. We're basically learning about CSV files, formatting data. Last time we created, in our utils module here, we created a read CSV function. It takes in a file path. We read that file path, and then basically what we do is we create an array of dictionaries, or a list of dictionaries. Each dictionary has a key specified at the top of the CSV file, and then the value. So this is one record, and it should have a key item and a value of eggs, a key quantity and a value of 0.5, a key unit and a value of dozen. All right, and that's all we did, that read CSV file, and it works with any CSV file we provided. Now, in a professional environment, you'd want to use some sort of library to do this, but it's important to try this stuff out on your own. Okay, and so you can get a better appreciation for what those libraries do and some of the common things you can run into. All right, read CSV. So what we want to do now is we're going to do a little data analysis. All right, so I have this file here called data_analysis.py. I'm going to make sure that it's executable. All right, and I'm going to import from my utils module my read CSV function. And basically, I'm going to be looking at my CSV data in all of these different CSV files, and I want to try to answer these questions. All right, so given customers.csv data file, what % of first name fields are left blank? Okay, so let's try this. Read CSV. We know we're going to have to look at the CSV data and customers.csv. All right, and we're just going to call this customers. All right, and we can print out the first customer just to make sure this is working properly. And now I can clear off where we left off before. Not running utils, I'm running data analysis now. Okay, so this gives us our first customer, right? And so what we want to do is we want to find a percentage of these dictionaries where first name fields are left blank, meaning the empty string. Well, if we want a percentage, we're going to have to use a little bit of math, right? So a percentage is the number that satisfy this constraint. So the number where first name fields are left blank over the entire number of customers, right? So how do we get the entire number? You know, that's total. That's just the length of our customers, right? We can print that out. Right? How many do we have? How many customers do we have here? Okay, we've got 1,256. Okay, so that's going to be the denominator. How do we find the number where the fields are left blank? All right, we can say blank first names. So I can use a comprehension to do this. I can say for C in customers, if C first name does not equal the empty string. Okay, so this is a comprehension. All right, comprehension. There's a for loop. It's basically shorthand for a for loop. This is the for loop for C in customers. So C is going to be each one of the values in the list customers. All right. Now, what is the result of this comprehension? That's over here on the left. The value that's going to be in the resultant list is going to be just that customer dictionary, right? C is going to be a dictionary because customers is a list of dictionaries. So C is going to be one of those dictionaries, and the result of this list is going to be that dictionary. However, here we have filtration. We're only going to have this value be a part of this list if the first name key of that dictionary does not equal the empty string. And actually, we want the percentage of first name fields that are left blank. So we only want that if it is in fact equal to the empty string. So this is going to give us all the dictionaries that are equal to the empty string, right? And then, you know, we could print out blank first name 1, you know, that first item in there just to make sure. And we'll comment this out. All right, so this should be all of the people that have first names and they left them blank. So let's take a look and see. And sure enough, this is first name is blank. Okay, so that's all we're doing here. And you know, what is the length of this? $66. Okay, so we have our numerator and our denominator, right? So oops, hate it when I do that. We have a denominator, and then we can say numer divided by denominator. Numer is invalid. Oh. There we go. All right. Now, it's important to note that this is not a percent, right? This is a decimal value. If I want a percentage, right, I need to multiply that by 100. Okay, that is a percent. However, we want to get rid of all of this stuff, and we also want to add a percent sign here, right? So we can add the percent sign fairly easily. We'll have a little space and then percent. Right, that should give us the percent. So, right, but we want to basically take the decimal point, two floating values. I believe it's not 2F. Let's see if I get this right. It's off the top of my head. Yeah. Okay, so this format strings are incredibly powerful. All right, this is the value that I am injecting in the curly brackets. This is the value, and it's a floating point decimal. I can add this colon and specify that I want this to be rounded to 0.2f, so 2 floating point decimals after the decimal point. Okay, very powerful, and that gives us the answer to the first one, 5.25%. So actually not too hard, right? That's all there is to it for this first one. And then if you have any others like this, you could check for last name fields that were blank or anything like that, and all you would do is change that, right? Nice and easy. Okay, so that's the first one. So let's print out the question. And then we'll add a couple print lines. And we'll do that for all of these. Let's see. There we go. All right, we'll run this and take a look at our sales analysis. Given the customer CSV data file, what percentage of first name fields are left blank? 5.25%. All right. What percentage of zip and state fields are switched? Okay, so it's a similar deal. We've got customers. We've already read this in customers. We don't need to read it in again. We want to find, we're interested in the zip and state fields that are switched. So we want another comprehension here, right? So this is going to be switched for C in customers if. So how do we know if they're switched? We can say if the type of C state is int, right? So if this is an integer, normally the zip code is an integer, right? So the state should not be an integer. So let's see what we get here. Let's print out switched, the first item we get, and we'll also print out the length of switched. So there's 17 of these. And sure enough, the state is the zip code and the zip is Illinois. Right? And to be a little bit more clear here, we would want to say we would want to make sure that the state is an integer, and you could make this more complicated. For this example, we don't really need to, because I've looked at the data, and if you wanted to make sure it was the zip code and not some other field, you would say state is greater than, let's see, it was 10,000, right? Because it's 5 digits, so the lowest number it could be would be 10,000, and then the highest number it could be would be 9,900 or 99,999. But then also you'd want to make sure the zip code is 2 digits and they're both uppercase letters, right? So in this case, the zip code is a string and 2 uppercase letters. So we could continue with this filtration, and make it more and more specific. But for this problem, this is plenty, just because I happen to know what the data looks like. So all we need in this case, this is enough to find it, right? If you didn't know what the data looked like, if you didn't have it and you couldn't actually find all of those, you would want to be more specific there. But this is enough. So we have the number of them, and we're just going to do the same thing, right? This is going to be, we have a numerator and a denominator, right? So the numerator is switched, and the denominator is customers, and print the same thing. 1.35%. Okay. All right, next question. What month saw the largest total revenue? Okay, so these get a little bit more complicated. So in these fields, we have sales data. Sales 01 is January, sales 02, 03, all the way through December. So we want to find out which month had the largest total revenue. So total revenue is the total amount of income from the sale of that item. That does not subtract any costs, and it also includes the sales tax for that particular region, right? So this one's kind of tricky. So we're going to need to know sales tax, and notice we have sales tax here by these values here, the state name, right? So this is a CSV value we have. And then we also we have products. So this is going to be product ID. These are fake products, right? This is what we're selling, and then the price is going to be in dollars. So the price is what the customer spends. The cost is what we spend to get the item. So when we want total revenue, that's going to be the number of these items times the price, And then we're going to also add on top of that the tax for that total. All right. So we're going to be looking at all these. So for the first one, we'll just find January. So let's find January first. That's a good place to start. All right, and so we know we're going to need I'm doing this as an array because I know we're going to eventually have this in a large array. So I want to read in the file it's a format string. This is CSV data slash and then sales, and we have a hyphen, and this is going to be a number, right? Months. All right, I might as well just go ahead and do this. I could say for month in range. This is going to go from 1 to 12. So I don't need the list here. I can say sales equals, I'll make this a comprehension. All right, and I'm going to read in, I want month, but the problem is we have a 0, 1, 0, 2, 0, 3, right? So I want this value, month, or we can call it M. I want this value M in here, but I need this to be, right justified, and I need it to be padded on the left with a 0 character. And I forget the exact format. It's something like this. We can look that up. Yeah, let's look up f-string padding formatter. Python. Look that up real quick. I always forget these format strings. So this is one type of format string. We want to look at the f strings. It definitely has the greater than symbol. Here it is. So it's the character you want to use, where you want to right justify, and then the number of total values. Yeah, so isn't that what I had? Let's look. The character I want to use, the number of total values is 2, because this is the window size. By window size, it's the number of characters. Right, so M is going to be a number. I didn't really even look at the error message. Oh yeah, so yeah, it did it right because my window was set to 1 instead of 0, 1. Right, but also this file name I need a .csv at the end. All right, so that should get it. So this was right, but this is the value I'm injecting in the curly braces. So M, it's an integer, and then there are these colon. These are these special format operations, right? I want to pad this with a 0, right? The content itself should be justified to the right, which is why the arrow is pointing to the right, because the content itself is going to the right side of the window of characters, and then the rest of the space is going to be padded with zeros. If I wanted to pad it to the left, I would just use the other arrow, right? So we can do this, and we can take a look at, sales 0 should be January, And then let's look at the first sale. So the first sale, invoice number 7500, customer ID 1699. Let's check. 7500, 1699. So that looks right. We had a fidget and there were 16 of them purchased, right? Product ID, fidget, quantity 16. All right, so that worked fine. All right, so we've got our list of sales, and we want to know which month saw the largest total revenue and what was the value. So we could say, excuse me, so let's just say January equals sales 0, right? That's our month of January. For line in, so each line, if we look at the sale data, each line is one product and one quantity. Now it's an invoice, so this invoice shares the same invoice number. So this is one transaction because it has the same invoice number, and also it's the same user ID, right? So this would be these here are all the same invoice number, right? But this person here bought different things: a fidget, 6 fidgets, a bauble, a gadget, doodad, etc. So we don't really care about the invoice numbers. We just know each one of these is a transaction. It's a product and a certain quantity. Now we're going to have to look in our products table to find the price, right? So we'll look up the product and we'll find the price. All right, so let's go. Might as well get our products. It's going to be a read CSV. All right, so that's good. Let's print out the product. Let's see if that's what we think it is. Product 0. I need to comment that out. Product is products. So we have a widget at a price $5.50, cost $2.83. Let's see if that's correct. Widget $5.50, price $2.83. So that's correct, right? So we've got our products CSV file, right? So this is working. So for each line here, we want to say for each line in sales, right? The January sales. Right, and we can take a look at that file. We want to know the quantity of items, right? So line quantity, and we want to multiply that by the price of the item. The item here is product ID, right? Quantity is the last field, product ID is here. So we want that times line product ID. Okay, and this is going to be the key to access one of the items in our products, right? So we need some sort of function that's going to scan this products list for a product ID. Right, so let's make a utility function for that. Define find in CSV. So we've got one of our CSV files, and we want to look in a column. We don't even really need we'll just use a comprehension. It's easier. So this product ID copy. You know, we're not multiplying by the product ID. This is going to be what we're searching for in the products list, right? So this is a list of products, and we want to look at the product ID field, and we want to find which one is our product, right? So we want to find we can scan through our list. Product in products. If that product's product ID equals, what we're searching for, then we'll return that product. Right? And there should only be one of these, so we'll take the first one. So let's see, for P in products. Right, so this, to summarize, this is a right here is a comprehension. It's a list comprehension. We're basically iterating through the list of products now, and for P in products. So if P product ID is equal to what we're looking for, which is this particular line item, right? This is what we're searching for. Then that item is in our list. Now, all of these only have, there's only ever going to be one match here. Right, so I'm just taking the first value, and that's the actual product. So here we have product, and I can use, I'm multiplying the quantity from the line item, and then product times price. Right. And so I might start with sum total equals 0, and then item revenue, I might say total plus equals the revenue. Right, but let's just print out revenue each time to see what we're getting. Print out revenue and see if it's right. We'll put an input statement after each one so we don't have too much output. Okay, so revenue for the first line item. Let's take a look at that. 207.84. All right, so the first line item is a fidget, and there's 16 of those. And let's look at the products. So $16 or 16 items times 550. All right, so right off the bat, this looks like we're not quite doing something right. Let's open a new terminal, Python 3. We should have 16 times 550. Right, and so that should be 88. So we've got an issue here. Let's take a look at our code again and see the revenue. So this is the quantity times the product price. Let's look at the products. Oh, it's a fidget, not a widget. So a fidget is $12.99. So this should be 16 times $12.99. Let's take a look at that. 16 times $12.99. 207.84, right? So that's correct. And then the next one, 51.96. So let's take a look at the next sales item. It's fidgets, and there's 4 of them. So $12.99 times 4. Let's take a look. $12.99 times 4, $51.96. $51.96. Okay, that looks right. Let's check the next one. $77.94. Okay, that's also a fidget. Let's just assume that works. Let's try a different one. $1.85. So that should be this one. One bauble. And if we look here in the products, we have a bauble, and it's $1.85. Okay, let's try one more. $129.87. Okay, so that's going to be sales. So 13 gadgets. So 13 times $9.99. All right, so let's take a look at that. 13 times $9.99. $129.87. Right? Is that what we got? $129.87. Okay, so this is working. So we're almost there. You know, if we get through this entire list, you know, we have that total at the end here. Our data analysis, we have a total, right? And we're accumulating this revenue, right? But there's one thing we're missing from the revenue is the tax data, right? So we need to get our tax data here. Sales tax, we'll call this sales tax. All right, we have our tax data. Now the problem is, you know, this is a little bit more complicated because we need to know which state we're in, right? So if we look at our sales data, we don't have a state. We do have a customer number, right? And so that means we're going to have to look up that customer number in here. And given a certain customer number, then we'll look at the state. Then from that state, we have to go to sales tax. Now notice that the state is just the 2-letter code, right? Whereas the states here, the states are a 2-letter code in the customers list, and then in the sales tax, we actually have the state name. So we need a translation layer here, right? We need to convert the 2-letter state code into the actual state, right? So we can do that by searching for, you know, postal 2-letter state codes. You could use a library for that. We're looking for something like this. So there's also, someone told me that there's a pip library that you can install called US, and it gives you the postal codes. But this is basically all we need. So we could just copy and paste this and, you know, up here somewhere, you know, paste this in here. This is kind of ugly. Let's see. New file. Alright, and so we can paste this in here, and basically what we want to do is scan this. We're going to write a real quick program to make a dictionary out of this. Get postal dictionary. We're gonna, this should be after read file. So I'm gonna read in a file, and the path to this file is states. Right, so states.txt. Get some data. If we look at this data, we see there's double new lines everywhere. So we can replace all the double new lines with a single new line. Right, so we can do something like this. Dot first strip off any data. We can replace. Oh, my read file function already does this. So I just need to replace new lines, double new lines with a single new line. Right, and then that should be the data. And then for, we could say data.split over the new line character. And so this is going to give us a dictionary where the long version of the state gives us the short version, right? So if we, oops, back to utils here, we could say I want to create a dictionary. This is going to be long to short. For I in range length of my list, but I want to start at 0 and go by 2. Right, so the reason I'm doing that is because I need to go for every 2 items in the list, because the first item in the list is a long name and the second item in the list is a short name. So I would say, you know, list I is the key and list I plus 1 is the value, but then I skips I plus 1 because we're adding 2 each time, right? So I'm basically pairing up each one of these values in the list, right? And this is going to be the long names to the short names. Do I want the long names to the short names? What do we have in our CSV data? This is sales tax. So I'm going to have a short name and I want to make it a long name. So I actually want this inverted, right? So I actually want, you know, I'm just going to call this a dictionary, but I want this to be the opposite. I want I plus 1 here and I there. And I'll just return DI. All right, and so I have my utilities file. And let's go back to data analysis here, and I'm going to, instead of importing CSV, I'm going to import everything. And down here, I'll say state conversion, and let's get the postal dict, and we'll just print that out and see what we have. Add a little pause in here. Okay, so now I have the short name to the long name, and that's what I want because the customers are going to have a short name and I need the long name to be able to access the values in sales. Now there's one additional thing you'll run into here, which, well, we'll cross that bridge when we get there. So there's our state conversion, and we have customers up here, and so we have the revenue, but we need to get the particular customer. So the customer, we have to search the customers for C in customers. If C customer ID equals, we have some customer ID here, right? And there should only be one value here. What is this customer ID? Where do we get that? We get that from our line item. So each line item in sales tax, right? So there, this is the invoice number and the customer ID, right? So line, so cust ID is line customer ID, right? And so that's what we're searching for here. So there we get the customer. Let's print the customer. Let's see if this is working. Customer, right? And we have the state, Texas, right? Now, because some of these values, sometimes the states have a bad value. The state might be blank, right? In that case, we don't know what the tax is, so we're just going to assume it's 0. So something we might want to do is, after we add in our sales tax, we might say sales tax. If we have the empty string, we're going to say the sales tax is 0. All right. Another thing on this one, assuming some of these are switched, we would want to, switch those back. So any of these fields that are switched, we'd want to, have some code in here to switch those back. All right, so we can do that to repair the data. So we could just say for C in customers, if that repair switch state and zip, if the type of C state is an integer, we know we have those switched, so we'll say the state field and the zip field should be switched. Oops. All right, so that should repair the data. Right, and what's left? We've got our customer. We've got our line that's got a particular state. Or no, our line has the customer ID, which gives us the customer, which gives us the state, and then we can look up the state from our sales tax dictionary. Right, so sales tax, we want to find the sales tax so sales tax is a CSV file, so we want to find the item where state is the longhand version. Right, so long state is going to be state conversion customer state. Let's print that out real quick, make sure this is correct. We'll comment that out. Sales tax. Oh, right. We need, this should be a dictionary. Append state is empty, and we'll say, so we're trying to mimic in here state, rate, and rank, and we're going to make this 0%. Alright, so state rate is 0%, and rank is NA. Alright, so we're just adding this extra one in case we don't have a state. is not defined. Dot. Okay, so Texas, we do get a long name, so that's good. So now we want, if we have the long state name, we want to get the tax record for that. So long state, right? T4, TN, right? And we're just going to grab the first one of those. There should only be one, and that is our taxed item. Grab the first one, 0. So once you do one of these, you're just doing more of the same. It's not really, it's a little bit more complicated, but there's not a lot of math in this. It's just correlate fields, and this is by far one of the most complicated ones. But you're just doing a lot of the same stuff multiple times, right? So we have the tax field, and we can look at that. Let's in that and run it again. Okay, so this is the tax field, right? So the tax rate is what we want, right? So we could say tax rate is going to be tax rate, right? But this has, what's the format of this? It's in percent, right? So the format, we want to remove that percentage character. And once we've removed that percentage character, we can print that off and we can see what tax rate is. And if we know what tax rate is, we need to convert this to, let's see, tax rates. Oh, tax rate. There we go. Tax rate. Okay, so tax rate is 6.25, right? But this is a string, right? If we looked at sales tax in Texas, it's 6.25. This is a string. We had to get it as a string because we had this percent character in there. So we took that off and it's 6.25, but it's still a string in our data. So we want to make sure we make this a float, right? And then we have a value that we can multiply. We can use this. All right, so now this is the tax rate, except this is a percentage. We actually want this as a decimal value, so we want to divide by 100. Do this again, right? And now what we're going to do is, so to get the total revenue of a particular line item, we want to add 100% of the total cost plus 0.06 of that cost, right? That's going to effectively be the total cost of the item plus the sales tax. So if I multiply by 1 plus this tax rate, right, that should be the total revenue, right? So we have revenue, which is the quantity times the product price, but we want to multiply that by 1, so 100% of that value plus the tax rate, right? 1 plus the tax rate. And that's actually going to be the total revenue. So let's actually do that down here. We want to multiply revenue equals revenue times 1 plus the tax rate. Right, and then we can just print out the revenue here. Let's try that. And there we get it. So that's 220. So let's see, if the tax rate is 6.25%, this is the tax rate. So we should be able to take 207.84 times 1 plus the tax rate, 220.83. 220.83. The only complexity in this is just keeping track of your variables and what types they are. There's not a whole lot of complicated math here. This is basic algebra. You do just have to, keep track of, the data, right? So we can go through here and we have the total revenue for a particular month. So our question is, which month saw the largest total revenue and what was the value? Right. So for each month we want to find a total. So we'll say totals equals a list. We'll start them all at 0. All right, and then so for each month here, so for each sale in sales, we're going to do this for each line in January. And all of this becomes indented now. And so for each line in sale, so sale is one particular sale month, right? So we don't need this anymore. And we could say in range length of sales, and then sale equals sales I. And the reason we do this is because we have totals I, right, that correspond to a particular month. So what we want to do here is we want to say totals I plus equals that revenue. And so now we have 12 distinct columns to track, or 12 distinct totals, the monthly totals, right? And we can comment this out. And let's just print out totals. Let's see if this works. We've got a key error. State conversion, customer state. Oh, so that is from my dictionary here. This dictionary doesn't have an empty dictionary. We need to add that. So in case there's a blank value, we're just going to keep that blank in our postal dictionaries lists. Okay, so there's our list. We actually didn't want to print that out each time through the loop. I'm in the wrong file. Data analysis. I just wanted to print it out once in the end. So I can say max equals 0 for t in totals range length totals. We have max, so this is an index value, total equals totals I. If total is greater than max, we'll set max equal to that total. And then we'll have max I. And we'll also set the max I equal to I. And then at the end of this, max I should be the index of the month, right? So we have the maximum and then max I. So we run this. It takes a little bit. It's a lot of data to process. Also, we're not doing this in the most efficient way. So the total largest revenue is this amount of revenue, right? And in the 9th index month, so this would actually be October, right? Because the indices start at 0. Okay, so that's probably the hardest one. This video is already too long, so we'll skip over this next one. I might make another video about that one. But you know how to format this data now. You would want to round this, right? You can also, there's formatting to help you add commas, and you'd want to add a $sign because this is a $sign, right? So that would be $432,557.66 in the month of October would be kind of the answer to this one. Again, it does seem like kind of a lot, but it's not really. It's all the same stuff. You know, once you figure out how to solve one of the problems, you can go through and solve them all. All right. So that's enough for this video here. I'll scan through the code once more so you can take a look here. Which must solve the largest total revenue. Well, what was the value? So we don't need that anymore. All right, but this is big data. This is data science. You have to solve the problems. You don't always have all the tools you need, right? So if you don't have the tools, like we had to make a dictionary to convert, you know, short state names to long state names, and you just have to make it work, right? So we had to add in sales tax for no state value, that sort of thing. All right, but this is data science. This is big data. All right. All right, so that's good enough for this video. Thanks for watching.